Now we're going to find the domain and range of each relation given below. There are 6 relations here. 5 of them are functions. 1 of them is not. So we'll start with x equals 6. X equals 6 is a relation. It is not a function. The graph of x equals 6 is a vertical line. This is what it looks like. Here's the graph of x equals 6. So let's give the domain and the range of x equals 6. Well, there's only one domain value. Guess what it is? 6. So we're going to say domain equals, and then since there's only one value in the domain, we can use set notation. Open curly brace, 6, close curly brace. Now if we look back here at the graph of x equals 6, we can see that we have every single y value from negative infinity to positive infinity. That means that the range of this relation is all real numbers, or we could write negative infinity to positive infinity. Now let's look at y equals 6. So x equals 6 has a graph that's a vertical line. Y equals 6 has a graph that's a horizontal line. Here, the range has only one value, 6, so we use set notation. The domain has every real number, so we can write all real numbers, or we can write negative infinity to positive infinity. Here's what the graph of y equals 6 looks like. It's just a horizontal line. Now let's look at this absolute value equation. So this equation is a transformation of y equals the absolute value of x. And let's think about what we do to the graph of y equals absolute value of x to get this graph. Well, x minus 4 means we're going to shift 4 to the right. Multiplied by 2 means we're going to vertically stretch the graph of the absolute value function by a factor of 2. And then plus 8 means we shift the whole graph up by 8. So we can use that to figure out what the domain and range of this function has to be. Since the domain of the absolute value function is all real numbers, and all we're doing is vertically stretching and horizontally stretching and vertically shifting